Good afternoon. Okay, thank you for joining us today for another presentation. Today it's going to be, oh, goodbye. Was it something I said, didn't say? Are you being called for your dinner? Anyway, it's a mixed up world, okay? So I've got a mixed up presentation for you. We've got so many new considerations in the production pipeline, from highly demanding shoots involving multiple camera systems through to new formats like 4K on the horizon. So we're going to go through a few bits and pieces. I've got a case study, which is all about stereoscopic ingest and all about very demanding environment. So how can we try and approach new production challenges and try and get our editorial done in a quick turnaround, especially when we add in 3D considerations as well. So we're going to look at that. That's the first thing. From there, we're going to go into looking at more at 4K. So we touched on some of that yesterday, but today we're going to talk about 4K literally from a scientific standpoint. How do sensors work? What are the formats and so on? So that's quite a sort of a heavy technical middle part. And then from there, we're going to look at some new technology around 4K and how 4K works in the acquisition in the field. So we'll be looking at sports, and we're going to look at the way that we can take a single 4K image and create a couple of different camera angles from one image, or camera pans if you prefer. We're going to look at that, and then we're going to round up once again with some more footage from the Norwegian program. Don't ever try this at home, which is an entirely file-based workflow that utilizes AJ products. And you're going to see various things getting blown up. So that's how we're going to finish. So we'll have a technical middle section, but there are some things being blown up at the end. So do bear with us on that one. So that's me. I'm Andy Bellamy. I'm the FSE for AJA in Europe. As a field sales engineer, I don't really know what that means because they get me to do all sorts of things. But by and large, that's what I am. So the first thing we're going to look at is called Taking Flight. So there's a program in Germany which covers a lot of really interesting outdoor pursuits, climbing, demanding, kind of challenging environments. And this doesn't seem to be right. Excuse me 1 second. Oh, that'll be why. That makes more sense. There they are. OK. So I don't speak German. Der Huberbaum is, I believe, a mountain. And these two guys are extremely proficient at speed climbing. So this was the first program in history, I think, in Germany that was a stereoscopic documentary. A very, very demanding documentary involving these two chaps who are speed climbers. Nice outfit. And they climbed this particular mountain, and they wanted to produce this in stereoscopic. And much along the lines of if you've seen things like Top Gear where they have a challenge, it's that kind of environment. Quite demanding. It was going to go onto television, as we say, and it was also going to be shown at film festivals. So what were the challenges of this particular shoot? They had to create a stereoscopic rig. Because the nature of climbing, you can't have various cameras positioned. They wanted to follow them from the side of the mountain. So they developed this particular stereoscopic rig so they can get really in close. Now this rig involves, I think, 8. You probably count them on there. I think there are 8 propellers on there anyway, all remote control. Very strange, harsh lighting conditions, so lots of heavy shadows and lots of bright light. So they've got a very demanding challenge in terms of how they could acquire the footage. So they're using the stereoscopic rig, as you can see at the top there, the 2 cameras. This is all remote control, remember, and we've got these speed climbers. You've really only got one go at this. So this can't be tethered. It can't have a tape deck, and it's not big enough to support a camera system which could be battery powered, which was solid state. So they had to use a recorder. So they used our KeyPro Mini. We talked about this a little bit yesterday, so I'm not going to dwell too much on the technology. Suffice to say, this is going to record ProRes or Avid DNX HD from those camera feeds. It's lightweight, it's durable. You could put it on the helicopter rig, essentially. So this is it there. So we've got the 2 units attached to it. Obviously, stereoscopic ingest is going to rely on 2 cameras running through. So solid state media, very flexible. We can just transfer that easily in terms of automation, push it into the system and get on with the editorial. So we're not wasting any time. We're going to save time. So in terms of who work with them, this is a company called Virtual Experience. They do various stereoscopic shoots. So we have a jib, I believe, as well. So this crane shot. So we were feeding into a lot of different AJA KeyPro recorders. So standardizing the mixed up shoot they're involved with. So they've got stereoscopic, they've got these other cameras, customized software that controls all the rigs. There's all kinds of things going on, but what we brought to it was a standardization of the acquisition. Everything was going to be ProRes, nice and easy. So I think we've got a nice shot of the camera system itself. There we are. So that's the thing actually running in the air. The 2Key Pro Minis. The whole thing weighs less than 2 kilos. So nice and easy. So in terms of the battery power that could run, nice and easy. Multiple flights up and down the mountain. They could record 20 minutes, which is pretty good, I think, in terms of, and that's not our recording limitation, that's the limitation of the batteries that the actual rig can use. So they would turn it around pretty quickly. They could actually get the footage out, get it into an Avid DS, get everything turned around and finished. So there was an hour of that stereo I think they took in, then the helicopter footage, and the DS, all natively in ProRes. Nice and easy. So in terms of standardizing it, that's how we did it with them. So it was a kind of a mixed up world for them, but we managed to bring ProRes throughout, up and down the mountain. I think this is online as well if you want to see it. YouTube has the 3D that you can look at. So I wanted to talk more about technical things today. Yesterday we kind of gave you a bit of a sell about AJ and how we do things, and that was a little bit in the previous demo. So today I want to look a little bit more into the technical elements of 4K. So we've come a long way. We mentioned this yesterday, SD being tiny by comparison, all the way up now to these huge, huge sizes of 4K in our workflow. We've been around a long while, and we've been working in 4K for quite some time. If you've seen 4K presentation anywhere, the likelihood is you've seen units that we produce inside of other people's hardware. So we do OEM boards that produce 4K pipelines, which literally is 4 cables for 4K. So I wanted to touch on what really do we mean by 4K? What does that mean in terms of its definition? Quad HD is really what we're talking about when it comes to a broadcast pipeline. And the reasons for that are fairly obvious. In terms of how we transport a signal and how we then want to bring a signal down to a pipeline which everybody has, if we times our standard HD up by 4, we roughly get 4K. It's just shy of it if you look at 3840 by 2160. That means we can acquire 4K that we can then deliver at HD. And the down convert is easy. So 4:1 as opposed to 1:1. It's nice and easy to do that, to bring that conversion. So we can match current television technology as well. That's really important. That's really important. We're not going to create any new formats. But just to be very clear, in terms of actual 4K for cinema, this is what that looks like. So 4096 by 2160, or 2160p, which doesn't really exactly trip off the tongue, but we'll get there with that, okay? Slightly more information. It means you could do a crop. You're going to lose a little bit, but it should be all right. Plenty more standards are available as well. So these are just some of them. You may have come across perhaps the digital cinema versions yourself if you've seen this. Acquisition formats, if you're talking to anybody with a camera system that does 4K, some of these will be amongst it. But by and large, for us in the broadcast world, we're going to be looking at working in the Quad HD version. Okay. So technically speaking, what do we do and how do we do it when we acquire 4K? So from lens to use, obviously light is the first thing that's going to pass through the glass, and that's going to hit a CFA, that's a color filter array, okay? And then to the sensor. From the sensor, we're then going to acquire raw data. Now that's something we're going to touch upon a little bit later on in the presentation. Raw data, just suffice to say, is massive, but we'll come back to that. We then have to debay to RGB. And again, this is all a bit mysterious for people who have never had any experience of Bayer sensors, but we're going to touch again a little bit later on about what that means. We're going to apply a LUT, so a lookup table to give us a particular visual representation of our acquired image. We're then going to compress if we need to, and then we're going to edit it. A lot of steps, and some of these are new ones to the workflow. RAW. What is RAW? RAW means different things to different people. There is a standard for RAW, an ISO standard for it, which is, again, it trips off the tongue, 12234 anyway. What does that mean? Nothing. Doesn't mean anything to anyone unless you're using it. So all the manufacturers that are producing RAW at the moment have a different definition of it. So that's an issue. Again, how do we try and standardize that? So this is all mixed up out there about who is going to do what and what they're going to do with their RAW and what the extension is at the end of that file. Red is a company that uses their Red extension, so they'll use Red code, various different compression ratios. That's just one way of doing it, but that's all lossy. You know, at the core of Red's encode is essentially a variant of a JPEG 2000 codec, so they're compressing even though it's deemed as a raw codec. So there's confusion about how this is really going to work. Most manufacturers produce their own decoding software. Canon do, and so on and so forth. Red use Red Cine X, and you need that in order to see the image in the way that it should be represented. So debaying, okay, we need to look at really what we're talking about with debaying. So this is taking a bitmap data from a raw image and converting it to RGB. How does that work, okay? It's always lossy, okay? So even though we've got the raw, as soon as we debay, we are going to be losing some information. And it's downsampling, which is going to reduce the amount of image information. So again, we've got the 4K image. We are doing some crushing of that on the way through. It's unavoidable. It's the nature of how we can manage the pipeline and acquire the image. If we go back to 1976, that was when the Bayer sensor was developed. So Bryce Bayer at Kodak did that. If anybody wants to see that up close, I can show you after class. But suffice to say, it's his invention. So Bryce Bayer, the Bayer sensor, and the debaying is how do we transfer that data from the sensor? So the filter pattern of the particular sensor we're talking about is 50% green, okay? So these are this particular layout was his development, and we're going to see there are different ways of doing this, but today we're mainly going to be talking about this particular configuration. So a Bayer arrangement of a sensor looks a little like that. The dominance in the sensor itself is green, okay? So without getting too in-depth about how your eyes work, we are more sensitive to green within the spectrum, and it's the way that we can combine our vision. It gets into how M&L cones work in the back of your eye. It's a lot of extra biological science around how we see that adds into this, but suffice to say, green is the highest sensitivity within our optical system. So in creating this sensor, it's a more accurate way of capturing data in the way that we see the world, which is very important. So each pixel is filtered to record only one of 3 colors, and the data from each pixel cannot fully determine the color on its own. So to obtain a color image, we use demosaicing algorithms to interpolate a complete set of red, green, and blue values for each point on the sensor. Very complicated. It looks a little like that. That gives you a better idea of how you see it. So that's the Bayer arrangement that we're talking about, and predominantly I'm going to be referring to the C500 from Canon. There are different ways of doing it, different sensors. So this gives you another idea of a CFA. So Kodak have an RGBW array. But again, you get the idea with this, right? We've got more green than anything else. That's how it's going to work. We also have another ways of doing it. So I think this is Nikon's. So this is a dichroic filtering system. So this uses specific wavelength variations in light to different photoreceptors to record the red, green, and blue wavelengths. So they use a dichroic mirror system to do that, which is what you could see on the bottom there. Again, highly technical, highly complex, another way of doing it. And what that's really emulating is triple chip, so CCDs. That's what we're talking about with that. So that's another way of doing it. So if Nikon suddenly produce a 4K camera somewhere down the line, it's probably going to involve that technology. And I think I've got one more here. This is a Foveon X3 sensor. And I'm not going to spend too much time on that. It's tremendously complicated how that works. But they use separate CCDs for each color. They don't demosaic. It's a sensor stack. So it's saturation through the sensor. And they're vertically aligned. Another different way of doing it. And while we're on it, one more. So Fujifilm, again, the predominance of green. This is more like we looked at before. But there's new technology emerging in this market in terms of 4K. Obviously, Sony have the F65. It's a fantastic camera system. And the F65 uses a completely different way of doing it. They turn the system around, so they angle the sensor itself 45 degrees, and that gives them a better spread, so they can actually sample at 8K. So if we show you what that looks like, and if you look up close, you can see the way that that's arranged. So we've still got that green dominance again, but they're doing it in a different way. So they trade resolution off for horizontal, diagonal resolution for horizontal resolution. That's how they can capture in more information and give you 8K sampling for a 4K output. So looking at how that works, it's not simple, okay? There's different ways of doing it. what you need to decide is which one is best for you. If you're looking at the C500, as I say, you need to be able to represent that data in a way which is going to be seen on set that you can understand it. Because if you're working with a Bayer sensor, you have a green dominant image, it's going to look green before you do the algorithm, before you actually do the debaying that you have to on that image. So you have to bear that in mind. You're not seeing what you're getting, okay? You have to debay to see that. The biggest consideration is the size of raw data. We are talking terabytes as opposed to gigabytes for minutes. It's a massive amount, okay? Now, once upon a time, I believe, and we'll all remember this, uncompressed workflows were going to be the next big thing. We were all going to work 10-bit uncompressed. But the files are massive, the throughput's massive, you know, and the gain wasn't a huge gain over using very good compression formats. So we're kind of back in that situation again where we have this option of RAW. Now the latitude of a RAW image means you can do an awful lot of pushing and pulling, crushing, zooming, scanning, panning, all kinds of things, and it's still going to look pretty good, right? So very challenging scenarios, challenging situations will really benefit from capturing that raw data. However, you're working with a great DP, you're working with a good team, you've got good lighting, maybe a compressed format is actually going to work better for you. Maybe that's the way that you should work. But the main consideration is, how are you going to deliver that to your client? How are you going to get it into the pipeline? Because if it's raw data, it's huge. We're talking delivering of RAIDs, you know, large amounts, terabytes of data. That's got to be a consideration because you could be blocking up the pipeline for somebody else and bringing in all this data, and they're like, well, what are we going to do with it all? So compression is to be considered. So working with a 444 compressive codec like ProRes is probably a good way to go. It's variable bit rate and will allow you to take that in to your system in gigabytes as opposed to massive terabytes of data. So that's one way of doing it. And obviously when we look at that ProRes file, we need to make sure that's debayed. So we are going to encode that and use a debaying algorithm. So that's something you're able to do with our technology. We do have a number of technologies which are not something which you can commonly buy. So it's not really something that you can buy off the shelf. But what I wanted to do is introduce you to a particular product that we do sell into technical markets. And this is something, if you have any need of application that is really a 4K powerhouse, and you have applications maybe in mind, or you're working in software, or you work with a software company which is developing around it, this is something I think you would be quite interested in. So Corvid Ultra is essentially a great big box, 2U rack, and inside this is a whole heap of fantastic technology based around everything up from SD, but essentially 4K is really what we're going to talk about here. So if you look at acquisition of 4K, say from a sporting perspective, okay, higher frame rates are important in that industry because they want to keep a smoother image. Now, if you're familiar with what's going on in the controversy around The Hobbit and its delivery to cinemas in 48 frames a second, thank you very much, James Cameron, for yet another new format we all have to adapt to. The first round of people going to see it were talking about how it was an unrealistic experience at 48 frames a second. It looks kind of hyper-real, almost television-like. That's maybe not going to settle down in a filmic fashion. People don't think it looks as nice as 24, even though it's a higher frame rate. Smoother 3D at the expense of looking a little bit more televisual. The opposite is true for television. If we're talking about sports, we're really going to benefit from a higher frame rate. Smoother pans, more detail, the ability to zoom in on an image, follow a tennis ball, much smoother, and also slow-mo replays become a reality on every camera position, not just high speed. So we can vary our frame rate into this 50 frames. So that's important. But again, we're working with Bayer sensors, as we saw. We've got to have a way of feeding this in real time and getting it into the mixers and getting it out there. And this is going to be a reality pretty soon. I believe most large companies working around 4K development will be having something like the World Cup on their horizon. A large sporting event is always a very challenging environment to sort of launch a technology. And if you look back through history, we went HD over sporting events. We went to 3D over large sporting events, football. So the same thing will probably occur again around 4K. Obviously, domestic infrastructure does have to change. We have to have 4K sets to see this. We have to have 4K set-top boxes and so on. So the next round of buying equipment for the living room is probably going to start again in around a year's time. So but start saving now, but it will happen. We will get there. Massive color depth is something else we're going to gain with this 4K technology, so 16-bit. But we keep going back to this debaying. We've got this image which is going to be very green dominant. We need to do something with it. So the Corvid Ultra allows you to actually debay on the fly in real time. So essentially what this unit is going to do is going to be able to take your signals in, and you're then going to be able to work with the actual content in real time out into the pipeline, 4K mixer, and then out into distribution and out to the living room. We can do LUTs in hardware. As we said, lookup tables are important. That's a particular look. If we have a particular look we want for content, that's where that's applied. So that's in hardware. We're not allowing a software operation later on. We need massive throughput, as we said. We've got big data, big files, so we need big throughput. So we've got roughly 2,500 megabytes in each direction. So bidirectional is a huge pipeline. So a real powerhouse to give you tons of bandwidth. The back of the unit has got pretty much everything you're going to need in the production chain. So 16 channels of AES CPU, RS422. So we can still control this and use tally triggers elsewhere. 4K cable, so the 3G SDI in and out. So bidirectional on that. That's very important as well. And the HDMI. Now, that's a 4K pipeline. It's a single pipe, but it's 4K. And there's obviously going to be some limitations to the color space we can get in there, but it will be 4K. So we should hopefully end up with one single HDMI for 4K for delivery in the living room from the set-top box. So it's not going to be 4 more cables in the living room, things like that. We're going to just have that one HDMI. Needs a PC, so you have to have massive bandwidth on the PC as well to help. So in terms of bringing the content and controlling it, we have to have a PC. Now, we don't produce any application for this at the moment. It's not something that we want to control. It's down to people like yourselves thinking about where can we apply this technology. So we have these option cards that we stick in the back of it. So you're able to see, there we are. So what do these do? Okay. So these are called true scale cards. This is where you can put proprietary technology under the hood, if you like, or write applications to use the 4K workflow. Okay. So in terms of those cards, what do they actually do? Well, they're called true scale. Again, the hardest thing in the industry ever for us as engineers is to decide what to call something. True scale is the name that was decided for this. So this is going to give you real-time scaling. So keyframeable, positionable, and the processing all takes place across the card. There's 2 particular points that we do this on the card. So I'll give you a visual representation about how we do that. We'll go back to the sporting analogy. So we've got our 4K source, okay? So one 4K camera, so for this example again, C500, big lens, we're shooting the football. We've got 2 3Gs coming out into our pipeline, and they're going into the box, okay? And if you just look at a one 4K image, that's what you're going to get. But we're going to get 2 bites at the cherry in a HD pipeline. So even though we've got the 4K on the horizon, if we're still in the HD world, that has to be delivered. And as we said, we can use 4K image, and then we can crop in on that. Again, I think we're in that mode where we're bringing in new terminology or new phrases that will catch on pretty quickly. Region of interest is what we describe the sub-clipping of a master clip in terms of what you're seeing. So via the TrueScale engine, we can take one image and output that. So that's HD output 1. Then we can take another image, and that's output 2. Now what we can do with that is we can control that, we can keyframe it. So a master pan across a crowd or similar is something that can all happen in hardware. That's pretty cool in terms of how that works. That's a frame delay between input and output. Yet it's 4K scaling, it could be moving around the image. We can crop within a crop within a crop and things like that if you really want to go crazy with it. But it's just a massive powerhouse of processing. And remember, we said before, we're bringing in big data that needs lots of processing, so you need a box that can handle that. And this is probably the direction you may go in. Now, that says live demo at the AJA stand. We haven't got a live demo here. We had it running at IBC. This technology is out in the industry at the moment. There's lots of key players out there who are using this to test the new pipelines, the direction it will go in. It's worth pointing out that everything we've ever produced from an engineering perspective has started out as a giant box somewhere on a desk in a lab in Grass Valley in California. We generally then try and make it smaller and smaller and smaller. So some of the key technologies in here are based in earlier technologies that we've developed, but most of the 4K technology here will cascade down into the rest of the range that we produce. So we'll be having converters that will be doing 4K and so on, and we'll have our I/O cards. So we have things like the Kona 3G already, which is 4K. That will then, we'll develop more cards down that route. At the moment, if you want to use this box, you can buy it, we can arrange that, but you need to have software for it. And at the moment, one of the main companies producing that software is Colorfront. And if anyone's familiar with Express Dailies. again, going back to this pipeline, going back to the fact that we can't see what we've got on our sensor till we debay it, color front is a way of bringing your dailies on set. So you're doing a 4K shoot, you want to then proof those in a theater at 4K, so you're driving a 4K projection system, or you're driving a laptop, or you're going into editorial, or whatever, we can take care of that in real time. So there's no debaying algorithm running on a computer, which then has to decode that, encode, and then deliver it. We can do it all automatically within the box, which is really cool. And having seen this work, there are various different formats there. So we've got C500 at the bottom. I think that's Lexa further up. We've got the red, and we've also got, I believe, an F65 at the top. So it doesn't matter to us. If we have the algorithm for the debayer, we can do it. So you put it on the card, and they use them in all of their software. We can then do that as a powerhouse, shove that through, and get the information out. And so we can see how we're working and how we're editing. I'm going to put the price up because I think it's worth mentioning. It's $8,000 for the unit, and then you pay about $3,500 for each card. That's okay, a reasonable sum of money to spend, but in terms of the technology you get, it's incredibly good value, I would say. And certainly if you were to try and look in other areas of the market, it's nowhere near that sort of cost-effective price bracket. So I don't want to terrify anyone about what's happening further down the line with 4K, but there are very strong engineering products which will be available that will assist you in that. The one thing, a bit like when 3D first landed, the one thing we can't help you with is the cost of a 4K display. That's really the bugbear, I think, at the moment. Throughput, storage has got cheaper and cheaper and cheaper, and it's going to continue to drop in value and increase in throughput. Processors go up, Moore's Law, all of that. We're going to get more and more power. We're able to do these massive computational edits and computational processes during our editing. All of that's acceptable. It's there, but you need to be able to see the 4K. That's the bit, I think, that will take a little time to settle down, but I know Canon have got good developments in that area, and we'll see more and more. I believe Toshiba and LG both have a domestic set that's available. Those are going to then, we'll see our industry adopt 4K monitoring at a level which we can all afford. So that's where we're going with 4K, and that's where some of the technology exists. We've got plenty of information online around the 4K pipeline. If anybody wants to have a close look at any of the stuff that we looked at technically earlier on, join us on the stand. We're F29 over in that direction. We've kind of gone over a lot of 4K. We've looked at a little case study at the beginning. I want to go back to where we were yesterday, which was a Norwegian television program called Don't Ever Try This at Home. Very demanding shoots on this particular program. It's based around an older Norwegian program where a couple of old scientists would do little experiments and so on. Essentially, they destroy a house every week. So they have a very demanding environment because it's exploding, debris, it's quite a dangerous place to work, and so on. So multiple camera systems, different ways of working, but again, backed up by using KeyPro and similar in order to standardize. So using compression from our products across the board. So that's kind of the background for it. The reality of the program is they try and debunk various things that you're not supposed to do. So running with scissors is one of them, putting umbrellas up indoors. They do everything from a minor kind of thing. Shouting indoors is another one that they cover, right the way up to what happens if you seal up your gas boiler and leave it on. What happens then? So they do all kinds of stuff like that. It's pretty much their top-rated show, and I believe it's going a little bit wider out into the wider community. So I think Discovery have picked it up, and there's various syndicated versions. So I believe we might have our own one in the UK. But I thought we'd just finish just by showing you a few clips from that. So move on to people blowing things up and running around with scissors. It is in Norwegian. It's not subtitled. They do swear, and they do swear in English. So I will give you a warning. There are some fairly fruity words in there now and again because they get quite shocked by what's going on. But the reality is the backbone of the program is all file-based. So the Norwegian broadcaster NRK are very advanced internally the way they work with their files. But anyway, I'll let them take up the rest of it.
Kroppen! Bensinskyting! Folketett! Har du halsen?
So this is Don't Shout Indoors.
Drikk kaffe.
Stå litt klar og pipa sånn, ser jeg.
Ai!
Her kan du holde liksom! Hva gjør du nå? Faen! Snakker du i telefon på Olav?
Rune, prat i telefonen her.
Ja, jeg skjønner det. Ja. Per Olav, gå ut av veien. Da kommer en bil, da kommer... Livsfarlig. Ikke gjør det. Ikke gjør det hjemme. OK, paraplyen usikra. Er det klart? Ferdig og fyr!
So use a phantom camera system, and that's all fed into a Keypro Mini.
Ja, sånn. Derfor er det du ikke skal slå opp kabelen innendørs. Livsfarlig. Hvilken vei stolen?
Oi! Den var close, men den
Er det litt nært, kanskje, at ting kommer ned igjen her på et vis? Er det? Og så
Oi!
som foregår i verden.
So that was Don't Ever Try This at Home. That's the Norwegian broadcaster NRK. So our kind thanks to them for allowing us to show those clips. We'll leave it there. It's a mixed up world, as we said at the beginning. So in terms of how we deliver, what we're going to bring in, AJ generally have something I think that will help with that. If you've got any particular considerations, do come and join us on the stand. We'll be happy to answer any questions or demonstrate any products. But thank you very much for your time today, and we'll see you again. Thank you.